Yes, student. Next one. Now what? Types of electrophilic substitution reactions of chlorobenzene. Okay. In haloarene, now I am specified the reactant. What? Chlorobenzene. You can take any of the halobenzene. Okay. But I am explaining by taking the example of chlorobenzene. Similarly, there will be bromobenzene, etc. Okay. So now the type of electrophilic substitution means by which electrophile we are substituting hydrogen of chlorobenzene. So on this basis, it will become type of electrophilic substitution reaction. So here the first one is nitration, okay, of chlorobenzene. Again I am saying, I am specifying the reactant, what? Chlorobenzene, and I am also specifying one of the, the next reactant. Therefore the reaction name is nitration of chlorobenzene. Okay, so first we have to write a proper chemical reaction and then we will check its mechanism. When chlorobenzene okay, is reacted with, okay, with concentrated, and now what? Nitric acid, that is what? HNO3. This is nitric acid. Therefore the reaction is termed as nitration. Nitric acid in the presence of now what? Catalyst. And again we have to specify the name of the catalyst. What? In the presence of concentrated sulfuric acid. Student, always remember, in the chemical reaction we have not to use the formula, we have to use their name, their proper name. In the presence of concentrated what? Sulfuric acid, then okay, then ortho nitro, okay, chlorobenzene, chlorobenzene, and one more what? Para nitro chlorobenzene obtained. Now student, which one will be the major product? The para nitrochlorobenzene will be the major product. Which is the major product? So this is called chemical reaction. For this chemical reaction, we have to write a chemical equation. So the chemical equation is when chlorobenzene, this is chlorobenzene, is reacted with concentrated what? Nitric acid, HNO3, okay, in the presence of what? Catalyst. And which catalyst is there? Concentrated H2SO4. Student, here the molar concentration of concentrated nitric acid will be higher and the molar concentration of concentrated H2SO4 will be lesser. Being its concentration is lesser and its concentration is higher, therefore, okay, the higher concentration having nitric acid will generate nitro electrophile, and therefore the electrophilic substitution reaction will take place by nitroelectrophile in ortho and para position. Thus, there will be what? Two product. Which two product? One of will be what? Cl, and there will be what? Nitro NO2 plus one more product will be there. What? Para directing, that is para substituted. So this is what? Cl, and there will be what? NO2. Okay, this is called what? Para nitrochlorobenzene. You can write the name para nitrochlorobenzene, because I am telling you again that as many times you can write the name, it will be better for understanding. Okay, now student, we have to check what? Its mechanism, and the mechanism is just like in previous video we have checked mechanism in 5 steps. That is what? First one, generation of what? Electrophile. Which electrophile? So specified here. What? Electrophile. Which one? NO2 electrophile. That is called nitroelectrophile. And now nitroelectrophile will generated by the reaction of concentrated nitric acid and concentrated H2SO4. So how to write this one? So very first write what? The structure of concentrated nitric acid. What is its structure? This is N double bond O, and there is a bond between what? N and O. Okay, so in this way you have to write nitric acid HNO3 plus now H2SO4. So how to write H2SO4? This is what? H, and now HSO4, that is H2SO4 is written in this form. Now you know that O is more electronegative as compared to oxygen, therefore electron pair will be shifted towards O, and here H is less electronegative than sulfur, therefore electron pair is shifted here. That means what? That means from here the OH will release, that is remove with its bond pair, and the H in the form of H cation, that is what? H cation. So now the reaction will be like that in this way. Okay, so it will generate what? N. Okay, and O2 you can directly write here what? NO2, but being electron pair is given to O, therefore the N will acquire positive charge, and here what? H2O will form H, and OH, it will form what? H2O. Okay, and there will be HSO4 an ion, because now the electron is taken by S, therefore HSO4 anion with what? Lone pair and negative charge. So this one is your what? First step. Now in the second step, okay, attack of what? NO2, okay, will generate what? Electrophilic site. Electrophilic site. So now the chlorobenzene, like that, chlorobenzene, this is Cl, there is what? H, and now NO2 is getting attack here. Okay, but when it come close, the first attack will not take place, but what? The pi electron is getting shifted towards adjacent carbon atom. That is called the generation of electrophilic site. So here the generation of electrophilic site takes place here. Like this is what? Cl. Now this is what? H, and lone pair and negative charge. Isn't it? This is called electromeric effect. Now what about the third? Now here in this electrophilic site, attack of NO2 takes place. Okay, how it is? this one, okay. Student, remember there is what? Positive charge. Okay, we have to mention it. There is what? Cl. Again, this is what? Positive charge. There is what? Hydrogen. And now the electrophilic site is developed here. And in this electrophilic site, the NO2 will attack. So, electrophile will combine here, and thus a new species will develop here. In this new species, you can see what? There is Cl with what? Plus charge. This is what? It's hydrogen earlier, and now the attack of what? Electrophile. And which electrophile? So specified its name. This is what? NO2. Isn't it? So third step is completed. Now we have two more steps. Why? Because we have to form main product. Okay. So the fourth step is what? Do you know fourth step? This is deprotonation. Deprotonation means removal of H in the form of proton. That is H cation. This is called deprotonation. So in deprotonation, now the species obtained, okay, in fourth step. That is this one. This is what? Cl. Earlier there is what? Plus charge. This is what? It's a hydrogen. This is what? NO2. Okay. And now the bond pair of CH bond is again taken by carbon. That is adjacent carbon. Thus now the NO2 will completely occupy the carbon position. This is Cl, but now the plus sign will remove because the electron is entered in the benzene ring, and the NO2 will position. Okay, but again I am showing you by forming ortho, but actually what? You have to explain by para. Even if you will write, then no problem. And the last one, what? Fifth step. Now look at in the mechanism. Earlier the two reactant, means reactant and catalyst, they develops, that is generate electrophile, water, and one more unstable species, HSO4 anion. Okay, student, in the fourth step you can see here, okay, the formation of hydrogen cation takes place, that is proton takes place. So now in overall reaction mechanism you can see two unstable species are there. So in the fifth step, these two unstable species will combine together. Like what? HSO4, this is what? Anion plus what? Proton released in the fourth step will combine together to form now H2SO4, that is the catalyst will regenerate. So the catalyst is getting regenerating in the fifth step, which we will again enter in the first step. So in this way, reaction and mechanism of nitration is getting completed. Student, this question is asked against 2.5 marks. In the 2.5 marks, for 1 mark, you have to write a reaction and equation, and for 1.5 marks, you have to write the mechanism in the 5 steps. So in this way, you can obtain 2.5 marks. Yes, student, next type of electrophilic substitution reaction is sulphonation of chlorobenzene. So similarly, again we have to write chemical reaction for this sulphonation process. What is this? When chlorobenzene is reacted with okay, now I am changing the specific reactant. What is it? With concentrated sulfuric acid. That is, this one is main reactant, sulfuric acid, with what? Higher concentration. Remember, okay, because in earlier reaction again the same what reactant. Okay, so with concentrated sulfuric acid in the presence of now the catalyst is concentrated nitric acid. Concentrated nitric acid. In earlier reaction, what we used? Concentrated nitric acid. But the catalyst were what? Concentrated sulfuric acid. Now I am changing it. What? Concentrated sulfuric acid is the main reactant which is used in higher concentration, and in lesser concentration the catalyst used, which is what? Nitric acid. Okay, then again two product will form, ortho, okay, and para. Okay, para substituted sulfonic acid substituted chlorobenzene form, or substituted compound is formed. Compound is formed. Okay, and para, okay, para sulfonic acid, okay, substituted compound is major product. So this is the reaction. Now for this reaction we have to write its what? Equation, and the equation is, this is chlorobenzene plus what? Concentrated sulfuric acid. So we will write it in the form of reactant, and the catalyst is what now? The catalyst is concentrated H2SO4, concentrated HNO3. So write it in above the arrow mark, which shows it act as catalyst here, and the concentrated sulfuric acid act as reactant here. So now the two compound will form this one Cl, and this is what? SO3H, sulfonic acid, plus in the ortho position, say Cl, and there is what? SO3H, isn't it? So ortho and the para substituted compound is formed. And which one will be the major product? This one will be the major product. Why? This is due to what? Lesser repulsion, being two functional group are present in opposite direction. But again I told you, to gain the 100% marking you have to check what? Mechanism. Same thing. What is the same thing? Generation of what? SO3H, okay, electrophile. So how it is getting generated? So again write its structure. This is S double bond O, double bond O. This is what? O and H, and there is what? Bond between S and O. Write it in this way, okay? That is in the form of Lewis dot structure. And now what about HNO3? The HNO3 is written in the form of H and the bond between N, HNO3. Getting? So when these two compounds are added, now what? The bond pair will shifted towards O, and this one is shifted towards N due to higher electronegativity. That means what? Here with bond pair OH will release, and here without bond without electron the H is getting released. Therefore the remaining portion will be, in short we can write this remaining portion as what? SO3H. isn't it? This is one of the electrophile. Plus H and OH will become what? H2O plus. Now the bond pair is taken by nitrogen. Therefore now the nitrogen NO3. So bond pair and so negative charge. That is what? Nitrate ion. This one is first step. Okay. Now what? Second step. What is this? Formation of what? Electrophilic site, as we have checked in previous mechanism. Electrophilic site. Okay. So electrophilic site on benzene ring. This is our what? Cl. This show H. Okay. And when SO3H attack on it, okay, that is come close to it, the energy is getting releases, to which the electron pair shifted to the adjacent carbon atom, forming electrophilic site here. So this is what? Cl. And now being electron pair shifted, therefore there is plus charge, and this is one of the hydrogen present here. Now the pi electron appears in the form of lone pair by forming electron efficient site, that is electrophilic site here. Means electrophile will attack here. And in third, what? Attack of SO3H, that is sulfonic acid, isn't it? So how it is on this species? So now this is benzene ring. Okay, there is what? Plus charge, and Cl is there. This is what? H, and what? Electrophilic site, plus SO3H, that is now this is getting attack on it. So now plus and minus will neutralize, forming a compound. But again in this species there is one electron deficiency. Where is electron deficiency? It is in this carbon atom. Okay, and now this one is H, and this one is what? SO3H, isn't it? And what about fourth step? So we can go for fourth step. What is the fourth step? This is called deprotonation. Deprotonation. Okay, that is H is to be removed. Okay, because here is the electron deficiency. So this electron deficiency must be what? Removed. So this is what? H, and this one is SO3H. And now there is a bond pair between carbon and hydrogen, which is taken by the benzene ring. That means now the stable compound, that is the main product, will form. This is Cl. Now the plus charge is removed. It is because electron pair entered in the benzene ring, and SO3H is completely attached here. And the last, that is what? Fifth step. What is fifth step? The H cation released from here. Look at H cation. Okay, this is H cation plus one species NO3 is present there. So these NO3, okay, anion will combine to form again HNO3. So this nitric acid will use as catalyst for the next reacting molecule. So student, in this way the nitration and the sulphonation can be explained. Generally these two questions are asked against 5 marks. That is, you have to write a complete reaction, then you have to write equation for it, you have to write the name of product, which product will be major product, so where there is what? Lesser repulsion, and then the mechanism. So this is the 5 marks question. You have to see this video 2 to 3 times, and then you have to prepare proper notes.